Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at St. Andrews Institute of Technology and Management, Gurgaon. This college is affiliated to Maharaji Dhanand University. Today I will discuss topic Bessel's equation of the first kind. So and also properties will be here. So in our previous session I told you about Bessel's equation solution, and our solution is of type summation x to the power n plus r into am, right? So we have our solution. 1 minute, okay. So we have our solution y is equal to a naught x to the power n and something like that, right? So in previous session we have already find the values a naught, a1, a2, a3, a4 and so on, and just put all these value in our y is equal to summation a to the am ar x to the power n plus r, right? So this is your Bessel's equation, and our first kind Bessel's function is j and x. That means we are finding j and x here, and Bessel's, it is also called Bessel's function, and it is also known as Bessel's function of first kind, right? So this is about Bessel's equation, and this is the solution of the Bessel's equation, right? We can see that y is equal to a naught x to the power n 1 minus x square upon 2 into 2 n plus 1 plus x to the power 4 and so on. That means we are getting all even terms, and odd terms values a1, a3, a5 and so on, all was 0 there, right? So we can write it in separate form a naught x to the power n and summation r is equal to 0 to infinity minus 1 to the power r x to the power 2r upon 2 to the power 2r r factorial n plus 1 n plus 2 and so on n plus r. This is our separate form. It means summation form, where a naught is an arbitrary constant, and a naught value is if a naught is equal to 1 upon 2 to the power n gamma n plus 1. This is your gamma n plus 1. In gamma n plus 1 you can write n factorial as, right? So the above solution is called Bessel function, denoted by j and x. This is your Bessel's function and it is denoted by j and x, right? Now thus j and x is equal to 1 upon 2 to the power n gamma n plus 1 summation minus 1 to the power r and x to the power n plus 2r upon 2 to the power 2r r factorial n plus 1 n plus 2 and so on n plus r. And we know that gamma n plus 1 is equal to n factorial, right? Now gnx is equal to x by 2 to the power n 1 upon gamma n plus 1. That means if we expand this function, when apply x n is equal to okay, when we are writing, just expand this as n is equal to 1 2 3 4, this equation. If you apply r is equal to 1 2 3 4, then your expansion is this like this, right? Now gnx is equal to summation r is equal to 0 to infinity minus 1 to the power r upon r factorial n plus r factorial x by 2 to the power n plus 2r. I told you gamma n plus 1 n plus 2 and so on n plus r, you can write it n plus r factorial. That means n minus 1 n minus 2 and so on. So we can write it n factorial. So same as it is n plus 1 n plus 2 n plus 3 n plus 1 n plus 4 and so on n plus r. So we can write it n plus r factorial, right? Now we are applying if n is equal to 0. So if n is equal to 0, so this term will be j0x is equal to summation r is equal to 0 to infinity minus 1 to the power r upon r factorial 0 plus r factorial x by 2 n plus 2r. That means 0 plus 2r. So we are getting j0x is equal to summation r is equal to 0 to infinity minus 1 to the power r upon r factorial whole square and x by 2 to the power 2r, right? Now if n is equal to 1, for n is equal to 0, we are getting this solution, and for n is equal to 1, So j1x is equal to summation r is equal to 1 to infinity minus 1 to the power r upon r factorial and 1 plus r factorial x by 2 to the power 1 plus 2r. And we can expand this series as x by 2 when r is equal to 1, 2, 3, 4, 5. So we will get this expression, right? Now, if n is replaced by minus n, so what will do means we have already put n is equal to 0, n is equal to 1, n is equal to 3 and so on. But if our n is replacing by minus n, then solution will be then j minus nx. That means this equation j and x positive n here. So we are replacing n by minus n. So j minus nx is equal to summation r is equal to 0 to infinity minus 1 to the power r upon r factorial gamma minus r n plus r plus 1 x by 2 to the power minus n plus 2r. That means we are replacing n by minus n. So our general solution of Bessel's equation is y is equal to ajnx plus bjn minus x nx, right? So this is your one complete solution for the Bessel's equation. That means for the positive integer n and also the negative integer n, and add both of them, then this is your complete solution. Just say, for example, in our ordinary differential equation, cf plus pi is the complete solution if your right hand side is not equal to 0. Same as it is positive integer solution plus negative integer solution, both will be our complete solution, right? Now, there is an example here. Prove that jn minus n x is equal to minus 1 to the power n jn x. So it can be asked in your semester exam and it will be 7.5 marks question. So jn minus nx is equal to minus 1 to the power n jnx. So first we need to know j minus nx value. So jn minus nx value, we know that summation r is equal to 0 to infinity minus 1 to the power r up 1 into 1 upon r factorial gamma r minus 1 n plus 1 x by 2 to the power this one. That means we need to learn all these formula, right? Jn x value, jn minus x value. If you remember jn x value, then you can write jn minus 1 easily. And the summation r is equal to 0 to n minus 1. So what we are doing here, we are breaking this equation, this series, from r is equal to 0 to n minus 1 and r is equal to n to infinity. That means we are breaking this as 0 to n minus 1 and here n to infinity. So that will be our negative integers here. So r is equal to 0 to n minus 1 minus 1 to the power r x by 2 to the power this one upon r factorial minus n plus r plus 1 and r is equal to n to infinity, same as it is. So that value will be 0 because integral value negative integers will turn to infinity. Here you can see r factorial gamma minus n plus r plus 1. So this integral, this value will be turns to 0 and this value will be remaining here, right? Now when you put 0, 1, 2, 3 here, so our value will be one by one step it will be lesser. That means value will be decreasing, and at n minus 1 at the last value we will get 0 here. That means our value is very less than, so it will be, whole term will be 0 and this term will be remaining here. So we can write this term as summation r is equal to n to infinity, same as it is. Now what we are doing here, on putting r is equal to n plus k, right? We are replacing r by n plus k. So j minus n x is equal to summation k is equal to 0 to infinity, r is equal to n plus k. So your n r will be replaced by k is equal to 0 to infinity and minus 1 to the power n plus k x by 2 to the power n plus 2k n plus k factorial and this equation. So just solve this and we will get k is equal to 0 to infinity minus 1 to the power n plus k x by 2 to the power this step upon n plus k and k plus 1 here, right? Because n will be cancelled out in this term. Now minus 1 to the power n we are taking outside from here because our series is minus 1 to the power r type. So we need only 1 here. So summation k is equal to 0 to infinity minus 1 to the power k x by 2 to the power n plus 2k upon n plus k factorial into k factorial. So we can see that, okay. So we can see here my this value minus 1 to the power n and this value. We can write this equation. We can see here that this equation is same as it is Jnx type. That means summation k is equal to 0 to infinity minus 1 to the power k x by 2 to the power n plus 2r. So r is replacing just by n here. So we can write this equation as minus 1 to the power n Jnx, right? So our proof is this: Jn minus 1 x is equal to minus 1 to the power Jnx. This is your property. We will use this property further. Right now, properties of Bessel's function. So this is also important. It can be asked maybe 7.5 marks question. So just prepare all these properties. First property is xjn derivative is equal to njn minus xjn plus 1. So you have to learn all these formula, because by use these formula 1 and formula 2, you can solve formula 3, 4, 5, right? So first formula, x into derivative of Bessel's equation. That means the derivative of Bessel's function ngn minus xjn plus 1. That means we will prove this one. So we know that jnx value, right? And we know we need differentiating value here. So we know first write Bessel's function here, right? This is your Bessel's function. Now differentiate with respect to x, because we need a derivative here. So just to find derivative, so just differentiate with respect to x. So this step same as it is. Now x to the power n differentiation formula will be applicable. So n, that means n plus 2r, x by 2 x n plus 2 2r minus 1 into x by 2 differentiation 1 by 2. Right now, we need next step x into jnx. So derivative of jnx, so just multiply by x on both side. So multiply by x on both side, then you will get x into jnx derivative is equal to summation. This is step same as it is. This is step same as it is. X by 2 n plus 2r minus 1 into x into 1 by 2 here. So minus 1 and 1, we can see here x by 2, right? X by 2 combined. So this is your base and this x by 2 base. So both base are same. So power can be added or subtracted. So x by 2 n plus 2 r minus 1 into x by 2 to the power 1 here. So it will be cancelled out and it gives this step. Right now, what next step, what we are doing here, we xjn dash n plus 2r. So just multiply by this one into n. So this is your first step, means n into this one plus 2r step is here. We can see here minus 1 is not here because it will be cancelled out, and I will just write here x into this one and it will be cancelled further. Right? So we are just doing this step n plus 2r n plus 2r. So this we are getting this step plus 2r step, this one. Now n into summation this value. This value is same as it is jnx formula. So we can write it jn plus. Now just convert this equation also in the jnx, that we can write it here. So summation r is equal to 1 to infinity minus 1 to the power n s plus 1. So what we are doing here, we are putting r minus 1 is equal to s. When you put r minus 1 is equal to s, then what will we have? Summation r is equal to 0 to infinity, that means s will be here. So s is equal to 0 to infinity minus 1 to the power s plus 1 upon s factorial n plus 2 x by 2 to the power n plus 2s plus 1. Right? So just arrange these terms. So s is equal to 0 to infinity minus 1 to the power s upon s factorial. This is step n plus 1 plus n s plus 1 x by 2 to the power n plus 1 plus 2s. So we can see here that summation r is equal to 0 to infinity minus 1 to the power r upon r factorial, some plus n plus 1 plus r x by 2 to the power n plus 1 plus 2r, right? That means we can see that we can write this equation as jn plus 1. That means n is replaced by n plus 1. बाकी सारी चीजें as it is and no change, but n is replacing by n plus 1. So it will be jn plus 1 formula, right? Just see and understand very carefully, because the calculation is much here, so just try to understand what is going on. Now our formula property second here, xjn derivative is equal to minus njn plus xjn minus 1. So we have jn is equal to summation r is equal to 0 to infinity minus 1 to the power r upon r factorial gamma n plus r plus 1 x by 2 to the power n plus 2r. So this is your jnx. What we need, derivative of jnx. So just differentiate with respect to x. So we will get this step. Now again multiply by x, because on left hand side we are multiplying by x. So after multiplication by x, you will get this step, right? Now again x by 2 base is here and x by 2 base here, so minus 1 plus 1 will be cancelled out and we will get this step. Now there is an change here. We are adding n and minus n here, means subtracting and add n here. So 2n plus 2r minus n upon same as it is x by 2 to the power n plus 2r. So we can write this step again, 2n plus 2r term one side and minus n term one side. So after breaking this step, we are getting r is equal to 0 to infinity this step x by 2 to the power n plus 2 1 minus n this one, right? So r is equal to 0 to infinity minus 1 to the power r, 2 is common, n plus r upon r factorial, n plus r plus 1. So n plus 1 gamma 1 n plus 1 is equal to n factorial, right? So we can write this gamma is equal to gamma n plus r plus 1 minus 1 into gamma n plus r, because gamma n plus 1 is equal to n factorial. So we can break this as n plus r plus 1 minus 1 into gamma n plus r upon into x by 2 to the power n plus 2r, and this value is equal to jnx, right? Now after solving this, we have r is equal to 0 to infinity minus 1 to the power r upon r factorial into 2n plus r, so n plus r will be cancelled out, and minus n. So we can see this step n plus 2 also j n minus 1x, right? This step we can write n plus r, so n minus 1 plus r plus 1, that means 1 is adding, 1 is subtracting, and also here n plus 2r minus 1, because we just multiply by x here and divide by x here, because x by 2 2 to the power x by 2 just multiply by here and just divide here. So x by 2 in dividing we can write it minus 1 here, and x by 2 into 2, so 2 2 2 will be cancelled out, so we will get this step, and we can write this step here, x summation r is equal to 0 to infinity minus 1 to the power r upon r factorial, n is replacing by n minus 1. So your gen minus 1 formula will be here, right? So hence proved. Now property third, 2jn derivative is equal to jn minus 1 minus jn plus 1. So we know that jn minus 1 jn plus 1. So in our first property we can see that xjn derivative is equal to njn minus xjn plus 1. Second derivative property is this one, so just add both of them. After adding, then you will get this your third property, right? You can see easily here. Now fifth okay, fourth property. So your fourth property is, okay, 2 and jn is equal to x jn minus 1 plus jn plus 1 formula. So we know that two formula in only jn minus 1 jn plus 1, property 1 and property 2. So subtracting both of them, subtracting second from 1, we get 0 is equal to 2 and jn minus xjn plus 1 minus xjn minus 1. So just write these two terms in the right and left hand side, so you will get your formula fourth here. And formula fifth is also here. That means property fifth is here. D upon dx, x to the power minus n jn is equal to minus x to the power minus n jn plus 1. Right? So this is our fifth property. That means we are just differentiating left hand side. So for the differentiation of this one, we know that xjn dash is equal to njn minus xjn plus 1, our first property, right? So multiplying by x to the power minus n minus 1, then we will get x to the power minus n minus 1 into x jn dash is equal to this step, right? Now just solve this. So minus 1 plus 1 probably cancelled out. Here also we can write it this one and this one. After solving this line, you are getting this step. Now we can see here that x to the power minus n jn derivative minus n x to the power minus n minus 1 jn is just write together and is equal to this one, right? Now we can see here d upon dx x to the power minus n jn. Why we are writing this one? Because this is the derivative of u into v. U is your x to the power minus n, so u as it is here, and derivative of second v, so v is your jn, so derivative of jn is jn dash minus the differentiation of u, so n and x to the power n minus 1 into v, and this same as it is. We can write this step and this one, right? So we property 6 is also here. D upon dx x to the power n jn is equal to this step. So we know that x jn dash is equal to second property minus n jn plus x jn minus 1. So multiply by x to the power n minus 1. So we have x to the power n jn dash is equal to this step. Now arranging again this step here, so we can see that this is your d upon dx x to the power n into jn. So this all these are your properties of Bessel's equation, and just prepare your all six properties, and if you have any doubt, so you can ask me, because these are the important properties, Lysander and Bessel's. So just try to understand and do your practice, right? Thank you. Okay, one thing I also told you that I have completed your unit second, and I will start your unit first in our next videos. So just prepare your unit three, second, third, and fourth. And then have any doubt, then ask me. Thank you.